So we can do the exact same thing here. We want to do, this is essentially the same problem. This is now in degrees, although we really should stick with radians. We can use degrees still because the symmetry is still the same. Now in this case we need to make sure we understand where the symmetry lies or where the positions are. So one full period from here to here, that's going to be where our 2 pi is, or in this case 360 degrees. And we want to find where this graph has the same cosine value of cosine theta equals 0.5. So this is what I'm looking for. I'm looking for where cos theta is equal to 0.5. And if I just draw my 0.5 value, I can see that I've got 1, 2, 3, 4, 5, 6, including the original point. So I'm going to mark those points. There's one there, there's one there, and there's one there, one there, one there. And again, the reason why I did those in different colors is if you take a look at those coordinates, all the green ones are related to each other. Okay, they are essentially coterminal angles, and they are separated by one period, or 360 degrees. And then the red values are also separated by 360 degrees. The red value is our theta 2 value that shows up in our graph. Okay, so then I need to figure out where all those points are. So this one here is, it says they gave it to me on my graph. The x value is 300, so that position right there is 300 degrees. Okay, and then I'm just going to go backwards 360, backwards 360, and I'm going to call those ones theta 1. So my theta 1, the first one was 300 degrees. If I go backwards 360, I'm at negative 60 degrees. Okay, and if I go backwards another 360 from here, I'm going to get negative 420. So there's negative 60. This one's negative 420 degrees, which is about the right spot because that's negative 360 there. So negative 420 degrees. Okay, so those are my theta 1 positions. Now I need to use some symmetry to be able to generate a theta 2. Oops, there's theta. I'll call that one theta 1. Where did I go here? Right one, there we go. Okay, so I need to find this red position. So I'm going to actually, I could use a symmetry from here at 360. Okay, and I know I went backwards 60 and I can go forward, so that must be 420 degrees. But I'm going to use actual formula that we usually use. So I know my symmetry from here, from 360 degrees back to 300 degrees is negative 60 degrees, and I know that to locate the same position, I'm going to go forward 60 degrees, so that position must be 60 degrees. So I call that theta 2, that's 60 degrees. And I know I can go forward 360 degrees to get my 420 degrees there. Okay, and then I can go backwards 360 degrees here. That's not quite to negative 360, and that ends up at negative 300 degrees. This one, what did I say that one was? 420 degrees. So that my last position then is negative 300 degrees. Okay, so there they are. I've got all my positions that give me this coordinate, this cosine value of 0.5. So we want to be able to use the symmetry. This kind of highlights the idea of theta 1, theta 2, but the idea is we just want to use symmetry to get around. Now I use a particular symmetry, but you can use any kind of symmetry you want. You could use a symmetry from the middle, right? As long as you know how to get the right measurements here. I think it's always good to try to use a standard position value of 60 here, or in this case 360 here, or sorry, 300 here, and we can use a symmetry going from this way and this way, from 0 this way and from 360 going backwards. Okay, but if you get stuck, you can use whatever symmetry you can find, and that's the key idea. Is we want to be able to use the symmetry of these graphs. So in closing, what is the difference between sine graph and cosine graph? Well, really there's not much difference. The shape is exactly the same. So there's my sine graph. Okay, let's sketch my cosine graph like that. Okay, oh, it's not quite good. Okay, so I'm gonna, here's my cosine graph here. Okay, and really the difference between these two graphs, there's not a big difference. The shapes are essentially the same. The difference is that one graph is just a horizontal shift of the other graph. So if I just grab that, if you take a look, I can just shift it over and it just matches the other graph. Okay, and I can shift it back. There's my original cosine graph, and I can just shift it 90 degrees to get my sine graph. So really they are just phase shifts of pi over 2 or 90 degrees. Okay, so the symmetry is the same. The values where we have to mark our symmetry are different, but the actual shape or symmetry is the same. We just, as long as we have an idea of the positioning, we can use a symmetry in the correct way.